This is a great question for revising composite functions, L'Hopital's rule, and in fact the chain rule. We're going to do this in two ways. The first way, we're actually going to calculate this composite function here, and the second way, we're going to avoid having to do that. The second method is actually quite a lot cleaner and better, although of course they both give the right answer. Okay, so let's have a look here. We're going to here's the first method here, which is by calculating the composite function. And here we're going to not actually bother calculating the composite function. Okay, so we have here that g of x is equal to e to the 3x plus 1, and therefore g of x is going to be equal to e to the 3. We have to replace the x by g of x. That's going to be e to the 3x plus 1 plus 1, that's g of x. So therefore g of e from this one here, which we're going to need, is equal to e to the 3e plus 1. So our limit here becomes the limit of x approaches 0 of e to the 3x plus 1 minus e to the 3e plus 1, that is basically g of e and g of x, over x. And putting x equals 0 into our limit, that gives us e to the 3e plus 1 minus e to the 3e plus 1 over 0, which is 0 over 0, which is indeterminate and in a form where we can use L'Hopital. Okay, so basically what we're going to do now is we are going to differentiate top and bottom. Well, obviously differentiating the bottom is no problem, but differentiating the top, we have to be very, very careful indeed. And this is one of the disadvantages of actually working out what the composite function is. So we need to differentiate e to the 3 3x plus 1 minus e to the 3e plus 1. That's basically the top part of our limit. So we need to differentiate that in order to work out L'Hopital. Now, of course, this bit here is a constant, so that's easy. So that equals here on this left-hand side, that gives us 3e to the 3e to the 3x plus 1 times by the derivative inside that bracket, which is 3e to the 3x plus 1. So therefore our limit becomes the limit as x approaches 0, obviously the limit of the bottom is 1, becomes the limit of, well, 3 times 3 is 9, e to the 3 to the 3x plus 1 times e to the 3x plus 1 over 1. This is by L'Hopital. And finally, we can stick x equals 0 into this, and it gives us 9e to the 3e plus 1 times by e, which is putting 0 into here and 0 into here, over 1, which equals 9e to the 3e plus 2. And that is the limit, and that's the answer. So we get the answer, but it's a little bit messy doing the actual differentiation of the composite function, and the reason it's messy is that we have actually calculated what the composite function is. Now let's not calculating our composite function. Let's have a look how we can do it not doing that. Okay, so basically we can we're not going to actually put the composite function in, but we can see that g of 0, here's g of x, so g of 0 is just putting x equals 0, equals e to the 3 times 0 add 1, which is clearly just e. So therefore g of 0 is equal to g of e, just putting in 0 into our limit. And so therefore our limit as x approaches 0 of g of x minus g of e as x approaches 0 becomes the limit of g of e, take away g of e over x, which equals 0, over 0, which equals 0 over 0. So basically that is our limit. Again, it's indeterminate, but we haven't had to bother doing the composite function or anything yet. We can go straight into L'Hopital now. Using L'Hopital, what we need to do is we need to differentiate this and this. Well, clearly, again, that's a constant, so all we need to do is differentiate that by using the chain rule. And the differential of g of x is going to be g dashed of g of x times by the differential within the bracket by the chain rule times by g dashed of x over 1, and g of e, of course, being a constant when we differentiate it, that is equal to 0. Okay, so this is all a little bit simpler. Right, now g dashed of x, we know that g of x is e to the 3x plus 1, so therefore g dashed of x is equal to 3e to the 3x plus 1, so therefore g dashed of 0 is equal to 3e, just putting x equals 0 in there, and we already know that g of 0 is equal to e, we've already worked that out. So basically we can go straight into calculating this limit, which we know is the same by L'Hopital. So we have that the limit as x approaches 0 is g dashed of g of 0 times by g dashed of 0 over 1, and that basically equals, well, g dashed of g of 0 is just g dashed of e, and that equals 3e to the 3e plus 1 times by 3e, which equals 9e to the 3e plus 2, exactly the same as the other way, except this way is far simpler because we don't have to bother calculating the composite function and dealing with some extremely messy, well, slightly messy maths here, and we get the same answer. So basically, I suppose if there's a lesson to be learned here is don't actually calculate what your composite function is in these types of questions unless you absolutely have to. Okay, well, I hope you found this useful, and if you get it in an exam, you use this little hint. If you like this video, please press the little thumbs up button and subscribe to the Gresty Academy YouTube channel. Thank you.